Assalamu alaikum and welcome you all. Today's topic is 4 basic parameters determining mechanical breath. These are trigger, flow, limit and cycle. I am Dr. M. Nurul Akhtar Hassan, Pediatric Intensivist and Associate Professor, Pediatric Intensive Care, National Heart Foundation Hospital and Research Institute. So these are the main 4 determinants of a mechanical breath: trigger, flow, limit and cycle. We shall go one by one in detail. First, trigger. Trigger is the mechanism of initiation of breath. How the breath will be initiated in mechanical ventilation. Second is flow. When ventilator deliver a breath, how the flow will be delivered inside the lung, whether it is constant flow or decelerating flow or other. Third is limit. Limit is actually size of the breath. Up to what limit the lung will be expanded to a certain pressure or to a certain volume. And finally, termination of breath is cycle. Breath will be started after triggering of breath, but when the breath will be terminated, that is cycle, after some time or after completing a delivery of some amount of gas. So here comes trigger. This is how the mechanical breath will be initiated. Triggering refers to the mechanism through which the ventilator senses inspiratory effort of patient and delivers gas flow or a machine breath in concert with the patient's inspiratory effort. That means machine will understand whether patient needs a breath or not. That is the trigger. If patient takes a breath or patient tries to take a breath, ventilator will understand and deliver a breath in concert with that. If patient does not take any breath, then ventilator will deliver after certain period of time as per setting of ventilator or inspiratory time. So there are two types of trigger, major classification: time trigger and patient trigger. Time trigger means the ventilator will initiate a breath according to set frequency, independent of the patient's spontaneous breath. Say we have set a respiratory rate of 20 in a ventilator. That means after every 3 seconds ventilator will deliver a breath. So during these 3 seconds, if patient does not take any breath, ventilator will deliver a breath after completion of this 3 seconds. So and this cycle continue, and this is time trigger or machine trigger. Patient has no effort or patient has no control. The second is patient trigger, where when patient tries to take a breath, ventilator will understand and ventilator will deliver a breath in concert with patient's effort. So if we consider the similar example again, we have set a respiratory rate of 20 in a patient. That means in every 3 seconds ventilator will deliver a breath. But before completion of this 3 seconds, if patient takes a breath or patient tries to take a breath, ventilator will understand that effort and ventilator will deliver a breath in concert with that. And after delivering of this breath, ventilator will again wait for another 3 seconds whether patient takes or not. If patient takes again, then ventilator will deliver a breath. If patient does not take any breath, ventilator will wait up to 3 seconds, and at the end of 3 seconds ventilator will deliver a new breath. That is time trigger. So this patient trigger can be of different type, but the most popular being flow trigger and pressure trigger. We shall discuss in detail about this thing. there are other form of triggers, but we shall not discuss in detail because these are available in some specific model of ventilators only. In a separate lecture of trigger, we shall discuss in detail. So, this is pressure trigger. In ventilator, you will find this setting as minus, so minus 0.5, minus 1, etc. How it works? This is the ventilator circuit, this is the inspiratory circuit and expiratory circuit, and here is the patient's end. When patient does not take any breath, inside this circuit there is zero pressure. But when patient tries to take any breath, ventilator tries to take any breath, there will be some form of negativity inside the circuit. If this negativity is more than what we set as trigger, then ventilator will understand patient is trying to take a breath and ventilator will deliver a breath. Say for example, we have set a trigger of minus 1 centimeter of water, and when patient is trying to take a breath, there is a negativity of minus 3 centimeter of water, which is more than the set trigger. So, ventilator will understand patient's effort and ventilator will deliver a breath, that is patient trigger, pressure trigger form. But there are other form of trigger, that is flow trigger, that works in different mechanism. In ventilator you will find these as positives like 0.5, 1, 2, etc. When patient is not taking any breath, inside this circuit ventilator will continue a constant flow from inspiratory limb to the expiratory limb. So, the amount of flow ventilator is giving, the same amount is going back to ventilator. When patient tries to take a breath or patient takes a breath, then some amount of this flow will go inside patient. Ventilator will calculate how much flow patient is taking. If this flow is more than what we set as a flow trigger, then ventilator will understand that patient is taking a breath and ventilator will deliver a breath. See, for example, if we set 1 liter per minute flow sensor or flow trigger, if patient tries to take a breath and takes more than 1 liter per minute flow from here, then ventilator will understand. But if the flow taken by patient is less than the set trigger, then ventilator will not understand, and this is the way ventilator trigger system works. So, in your ventilator you will find pressure trigger or flow trigger, both may present, or in older version of ventilators flow trigger may not be present, you will find only pressure trigger. So, pressure trigger you will find as negative like minus 0.5, minus 1, minus 2, etc., and flow trigger is positive. So, which one will use, pressure or flow or both? You cannot use both, either pressure or flow trigger. Most of the literature says flow trigger is little more sensitive than pressure trigger. So, if your ventilator have pressure trigger or flow trigger both, then it is better to use flow trigger. But in older version you may not have flow trigger and you will have to use pressure trigger only. On the other hand, if your patient is having auto trigger or too much sensitivity, then changing to pressure trigger from flow trigger sometimes helps. So, if there is too much auto trigger, you can put into pressure trigger. Now comes to flow. When breathing, mechanical breath is started, ventilator will provide some amount of gas inside lung. So, how the gas flow will be delivered inside the lung? whether it is a constant flow like this. This is the flow waveform in volume control or volume limit ventilation, and this is the pressure waveform in volume limit ventilation. In volume limit ventilation, flow is constant flow. That means at the beginning of inspiration there will be maximum flow according to set, and this maximum flow will be maintained throughout the whole inspiratory period up to the end of inspiration here. So, this is constant flow. As a result, as there is constant flow is delivering inside the lung, pressure will be gradually increasing, and at the end of inspiration there will be maximum peak inspiratory pressure. So, in constant flow or square waveform flow is actually the system in which volume control ventilation or volume limit ventilation works. Here higher end expiratory pressure is achieved as there is constant flow. On the other hand, in pressure limit ventilation, this is the flow waveform in pressure limit ventilation, and this is the pressure waveform in pressure limit or pressure control ventilation. In pressure control ventilation, maximum flow will be delivered at the beginning of inspiration up to the level to reach set peak inspiratory pressure. When set peak inspiratory pressure is achieved, ventilator will stop delivering flow and then continue to decelerate the flow as the inspiration progress on. To maintain this constant peak inspiratory pressure throughout the inspiration, from beginning of inspiration to end of the inspiration. So, flow will be decelerating in such a way so that pressure does not increase in lung. So, this is decelerating flow available in pressure limit ventilation. So, traditionally pediatricians worldwide use this pressure limit ventilation mostly, but there is no superiority of pressure limit versus volume or volume versus pressure. Anyone can be used. It depends on how comfortable you are. What we have said earlier, in pressure limit ventilation, as there is decelerating flow here, pressure will not be increased, constant pressure is maintained, but in volume limit higher peak pressure is achieved at the end of inspiration. In this way also pressure limit ventilation theoretically better. Then comes cycle. What is cycle? So, with trigger ventilation started. When with trigger inspiration started, but when the inspiration will be ended, that is cycle. Determination of the end of inspiration is cycle. Most commonly determined by time variable or time cycle, that is inspiratory time or Ti. So, after a certain period of time the inspiration will be ended as we have said in ventilator. But in some modality there is flow cycle. Flow cycle is available in pressure support ventilation or pressure support mode of ventilation. In flow cycle, inspiration will be ended after delivering a percentage of flow. So, in pressure support mode, inspiration ends once the rate of flow declines below a set threshold, usually from 1/4 to 1/2 below the peak inspiratory rate of flow. Usually in ventilator you may not need to set this thing because ventilator by default set 25 or 30%, and you may accept that thing, and you may not need to worry about it. So this is the pressure support ventilation, which is actually patient trigger and flow cycle. This is pressure waveform in pressure support ventilation, inspiration, expiration, inspiration, expiration, and this is flow curve in pressure cycle, pressure support ventilation. This is inspiration and this is expiration, and this is volume curve. So what happened here? At the beginning of inspiration, flow reach its maximum to reach a peak pressure of this pressure support level, what we have set in ventilator. So if we set a pressure support of 15 or 20, up to this point will be reached. So maximum flow will be achieved to reach peak pressure up to this level, and then flow will start to decrease gradually, as this is pressure limit. So this is the peak flow level where it is 10 liter per minute. If we see here, it is almost 10 liter per minute. So at the beginning of inspiration, 10 liter per minute flow has been achieved. So exhalation occurs at set percentage of peak flow, as we discussed earlier. So if flow cycle or exhalation trigger is set at 30%, then as our inspiratory flow is 10 liter per minute, as the flow gradually decreased over time with the inspiration going at the inspiratory at the end of inspiration, says as time going, and pressure is going down, flow is going down, and when 30% of this flow is achieved, say 30% of flow will come to almost 3 liter. So when 3 liter flow has been achieved, the inspiration will be ended. So I want to remind you that in pressure support ventilation, we don't set inspiratory time. So it is not time cycle, it is flow cycle. When flow decrease to a certain point, the inspiration will be ended. Let us say other example. Hopefully it will help you to make your understanding more clear. So this is first example. Flow cycle is set to 10. So this is the peak flow, maximum flow, 100% of flow, and as the inspiration goes on over time, flow is going down, flow is getting reduced, and when flow is coming to 10% of maximum flow here, then inspiration ended and expiration started. Here flow is set to 25%. So when after maximum flow, flow is getting reduced, decelerating, and when it comes to 25% of the flow of maximum, then inspiration ended and expiration started. And same thing happened in 50%. Here 50% of the flow is achieved and inspiration ended. So here 10%, 25% and 50%. So when flow cycle is finished here, inspiratory time become much shorter, inspirations ended early, and when 25% it is, inspiratory time is little longer, and when 10% flow cycle is given, inspiratory time is much larger. So you can adjust inspiratory time in pressure support ventilation by this way. You cannot set inspiratory time directly. So this is flow cycle. Finally, we have come to limit. Limit, as I told earlier, this is the size of the breath. During a mechanical breath, the parameter that limit the flow of gas during the breath to a certain pressure limit or certain volume limit. How much the lung will be expanded to a certain pressure or to a certain tidal volume or tidal limit. So, these are the two general methods, volume limit or pressure limit. In volume limit, lung inflation volume, that is tidal volume, is pre-selected and fixed amount of tidal volume will be delivered inside the lung, but the inflation pressure inside the lung will be variable because we are not setting that thing. We are delivering a fixed amount of tidal volume and pressure will be according to patient's lung condition. If patient lung is not good, like there is pulmonary edema or lobar pneumonia or atelectasis, lung will be stiffer and there will be higher inflation pressure. On the other hand, in pressure limit ventilation, we are inflating the lung to a fixed pressure, but inflation volume will vary. How much tidal volume will be delivered inside the lung will be variable because we are inflating in a fixed pressure. See, if lung is okay, then it will deliver a good amount of tidal volume, but if lung is not okay, there is atelectasis, pneumonia, then volume delivery will be reduced. We have come to the end of this lecture. Let us recapitulate again. There are 4 determinants. Triggering is the initiation of breath, how the breath will be initiated. It can be flow trigger or it can be pressure trigger, or it can be time trigger. If patient does not take any part, then it will be time trigger. Machine will deliver a breath if there is no patient's effort. Other form is electrical activity of diaphragm. I am not going in detail here. In separate lecture we will discuss this. Then pattern of flow. During the inspiration, how the lung will be expanded with the flow, whether it is constant flow or decelerating flow. In volume limit ventilation it is constant flow, and in pressure limit ventilation it is decelerating flow. Third is limit, how the lung will be expanded to a limit, that is the size of breath. Lung will be expanded to a certain volume or to certain pressure. And finally, cycle, how the inspiration will be terminated. The inspiration will be terminated after a certain point, certain time, like after certain period of inspiratory time or after delivering a percentage of flow. So, either it is time cycle or flow cycle. So, we have to understand these 4 basic determinants to provide mechanical ventilation more appropriately and to understand abnormality and asynchrony. Thank you all.